So earlier today, someone on the Rands Leadership Slack posted a great prompt to show kind of a shortcoming of Claude and ChatGPT. And I think it's a great example of how tools can be used to make LLMs substantially better for our experiences. So I built an MCP server to solve this problem, and I just want to kind of go through how this works. So the original prompt was plot these locations on a map. And when you do that in Claude, Claude tries and kind of builds this SVG over here that really doesn't match what we'd imagine, right? We expect a map out the other end. And when I tried that prompt with ChatGPT using the O1 model, the first option was create those things in Google Maps manually, which isn't a great response. And then, hey, just create a KML file and like put all your coordinates in here, which also isn't a great response. And neither is the third one. Just, hey, use a map service to build your image. So if I try out GPT 4.0, the response isn't that much better. So Google just returns a map of the place in France and then tells me to look at these locations and that I can use a mapping service. So let's try that same prompt using the Claude desktop app. And you'll see here that there's this little sign. I've added and I've built my own tools. And so the two tools that I've created here are create a map from GeoJSON, and it creates a map image from a GeoJSON, and then get GPS coordinates. And so if I paste in this prompt, the very first thing that's going to happen is Claude is going to ask me if it's all right to use this tool. And so I'm going to hit yes. And so from there, Claude is going to try to get all of the GPS coordinates for each of the places in the list. And so that will be useful in order to plot all of them. But you'll notice I also have a lot of requests here. And Claude, depending on whether or not you're on the Pro version, has a limited context window. And so that means we can only fit so much action or so much response within our initial request. Let's see whether or not this request fits within that context window. Now I'm on the Pro account for Claude, so that's 200,000 tokens. So we'll see if this unit of work happens within that 200,000 token context window. All right, so it's gone through all of the get GPS coordinates here. We can see what the request was to the API and what the response was. And so now I'm going to allow it to call out to my image generation tool. And it popped up in my other window, but I can drag it up, and there it is. So I have my created plotted image with everything in it. So let's jump in and let's see in the code how this works and how you can create your own tools using Model Context Protocol. Alright, so now I'm in the code for my map demo, and I can take a look and see. The very first thing that I'm going to need is to set an environment variable named geo_API key. Now Claude has a very specific configuration file called Claude desktop config. The Model Context Protocol for now only works with the Claude desktop and a few other editors. But those other editors are mostly focused around editing code, and they're not specifically around just text-based chat. So in this case, what you need to do is you need to add the configuration. And so even though this looks like a bunch of stuff, it's not really that complicated. So the very first thing that we have is this UV command. Now that is used to manage the dependency installation for all of the Model Context Protocol applications in Python. But it's not limited to Model Context Protocol. UV is just a really great new package manager that you can use everywhere. So in this case, what we do is we use UV to set the directory. And if you're going to use this, you're going to have to change this path here to where you've installed this repo. And then we're going to run. And then we specify dependencies here. So each -- with is going to, every time this gets run, pull in these dependencies if they don't exist. So we're asking UV to install fast MCP, which is what runs Model Context Protocol, the requests library for Python, Folio, which we use to generate that image, Selenium, which will spin up a web browser in order to create that map image, Pillow, which I used earlier, but I don't think it's actually a requirement now, and then it's going to fastmcp run, and then the path to this file specifically, the server.py. And then here we set our environment variable, right? And so you would replace this with the geo API key that you get from the geo API-ify MCP server. All right, that's a lot, but let's run over into the server now. So the very first thing that we have here is this from mcp.server .fastmcp, import fastmcp, and there's image. So one of the things that I tried to do originally is to have the image result be returned right within the chat, right? And so if I'm pulling up Claude and we were in here and I would have an image be returned instead, right? When we made that original image, it popped up in our Mac OS image viewer. The problem I ran into is that I ran out of context in order to embed that image. And so I got errors. So instead of doing that, what I ended up doing is I did a subprocess.run. And so what this does is it runs open, which is a command on Mac OS that opens up files, and the temp map. And so it just opens up a file that gets created on the disk in this directory. Okay, that's kind of a little bit of a detour, but it's important. This image return would have been a response type here. So my tool could instead return an image that is formatted in the model context protocol, but it just didn't work for me. I tried resizing the image to be 200 by 200 pixels, and it just didn't work. It just didn't fit within that context. And so instead, I put the return value as a string, and my tool now tells Claude, map image created at the current directory in the file name temp map and shown to the user. Okay, moving on from there, requests. If you've used Python before, you've probably used the requests library. It basically just allows you to make web requests, and it's what we use down here to actually call and encode our address. The next thing that kind of is important here is that we have this generate image that we import, and the environment variable getting imported here too. And so we saw in the configuration how we set the environment variable. We want to raise an error if that thing isn't there, because the thing won't work, right? This server won't work if we don't have an API key. And then next, we create the MCP server. And so this is fastMCP's version of like working really quickly. And so a key component here, which was confusing for me, is this dependencies thing. And so hypothetically, it didn't work for me. This would automatically put all of those dash with that we saw in the configuration automatically when you do an MCP install. But it didn't work for me. I had to manually put those things in. But hypothetically, this would be how you would say all of the libraries that you need in order to run this. All right, moving on. This get geocode is really what does all of the work. This is basically the entire thing, right? It's a web request that takes in an address and an API key and returns GPS coordinates. Now, one thing you'll notice here is I just return these raw JSON results. I don't try to filter for just latitude and longitude. I just spit the whole object back out at Claude. Depending on how big your responses are, you might not be able to fit those responses into the context window that's available for Claude. And you might need to be more deliberate about removing things or reformatting the response that comes back from your API you're trying to integrate with. But in my case, it just worked. And so I didn't need to worry about it. All right, so that's the first tool. That is the thing. This is all of the code right here. This is all of the code that's necessary in order to hook up an API to Claude and tell Claude about it, right? Very, very straightforward. Now, it gets a little bit more complicated when we start talking about media. I mentioned before that Claude couldn't fit the image into the context for it to be in that chat. I couldn't have the image that gets generated be returned back to Claude and just shown right in line. It's unfortunate, but what I do here is I call that generate image library, right? And I pass in a file name to use here. So one of the things that I could do here is I could actually change this. I could add another parameter that Claude needs to come in here saying file name, right? And we'd say it's a string. And so Claude would automatically know, and we could do something like this. File name .png, right? Like that. And Claude would automatically know that there was a parameter it needed to provide called file name. And so if we go over here, let's actually look at this generate image. So in the same directory, I've got this generate image, right? And if we go back up, you can see I import generate image right here. So if I go over here, we can see how this image gets generated. And so this was actually generated by Claude. It was a different prompt, but the basic prompt was, hey, create a thing, a program, a Python program, using Folium and Selenium that generates images of a GeoJSON input. And so this took one shot, like that prompt straight to this code generated. Once the code was generated, there was just one more thing that I wanted to do, which was have the ability to take in a GeoJSON file from the command line in order to be able to test it out and make sure it worked. And like one other thing I could have done here, right, that I didn't do, is I saved to a file. I could have just kept an open image and passed it back to the server and returned that image. And so that's why you see these kind of things like import image as pill image, because I was thinking originally that I would create an image in memory, right, not write it to disk and then reopen it, but create an image in memory from this application and send it back to Claude. But that just didn't work for me. But that really is the whole application. And with that, there's a whole bunch that now gets added. And what's really interesting about it is that Claude can pick and choose the tools necessary. So you can see, kind of if you look a little bit further out, you can see how a whole ecosystem of tools becoming discoverable to Claude or to other LLMs could be used to coordinate and do kind of more interesting work than we expect out of LLMs. But yeah, I hope this was useful.